So welcome everybody. I'm going to use this video to go over how can.Map works with a bunch of other people at Bitovi. The people at Bitovi, if you guys have a question on why something works the way it works or don't understand what I'm saying, please stop me, because if you don't understand, almost certainly somebody else does not. So with that in mind, let's go over it. So can you guys see my code?
Yep.
All right, awesome. So let's talk about can.Map and how it works. Okay, so can.Map is one of the core observable utilities, or I don't know what you want to call it, libraries of can.js. It allows you to observe key value pairs on something that looks like an object. And so a lot of its functionality, and also lets you do read and write nested properties. So a lot of when you're reading, writing, or removing properties, it's broken up into different phases. The phases are when you're getting the nested property. There's kind of one set of functions that are used to, for instance, for get. I'm going to go get the internal nested property I'm actually trying to get. Or set. I'm trying to get the kind of internal value I'm going to set. That's one layer. Is triggers. So like underscore set. Once you've found your actual object you want to set, double underscore set triggers events because a change has happened. And let me actually increase my font size here. And by the way, this is this for those who this is take your brother to work day. My brother, who wears a can.js sweatshirt like every single day to school, is how can.Map works right now. I might have questions. I doubt it. So then the final layer is the actual getting and setting, where you're actually committing a value to be stored on the observable, and that's a triple underscore get, triple underscore set, and triple underscore remove. So that's a lot of, the functionality is mixed in with these functions. There's also two other functions, underscore get attrs, which handles getting multiple attributes, and underscore set attributes, setting multiple attributes. And then there's two side auxiliary functions that do other functionality. One is bubble.js. That handles event bubbling from child to parent, and map helpers, which just it helps with some kind of with cycles and things like that, which we'll get into what that means for serialization and when you're instantiating, dealing with cycles. So let's walk through it. I'm not going to talk about the setup very much, other than to say that the static setup, so whenever a new map constructor function is defined, there is a computed property names variable which stores the list of any computed property names, and there's a defaults object which stores any default values that every instance of this type should be created with. And then there's a little bit of functionality that loops through that, loops through everything in the prototype, and if it's a looks if it is a computed property, then it sets up the computed property names to know to create a computed property. And if it's not a function, it's a default. Adds that to defaults. So come back to some of this if I need to. Let's talk about what happens when a new instance of can.Map is created. When a new instance of can.Map is created, if it was passed a map itself, well, we're going to serialize that map and use this object's data underscore data, and then we're going to set up any computed properties. And I'll talk about how computed properties get set up in a moment. And then the next thing I'm going to do is I'm going to say that this object, I'm going to kind of mapping. Actually, I'll kind of jump to it and explain it. Map helpers. So there's this problem where is it? Okay, you can see this little example right here. If I have an object, and let's say I created, Jack, can you close that door? If I have an object and I'm creating a map with object 1 as a reference to that object and object 2 as a reference to that object, can.js will make sure that even this object will be created as a can.Map. Only one instance will be created so that what object 2 points to is, or object 1 points to, is the same thing as object 2. This can actually be a little tricky. This isn't how can.js worked at first, because we just would loop through each property and then create an instance for what we see there. We do a little logic to see that, oh, we've already seen this instance before. Well, reuse the instance we've already created as the object 2 attribute. Anyways, part of that logic, what you need to do is say that for every object that your raw data that was passed to create the instance, you label it with what instance is being created. And this does some stuff under the hood, and it returns a teardown function if this is kind of the first time add to map is being called. Then setup defaults returns the default values. We're going to extend a base object with the default values and then extend that with the data that was actually passed in. And then we call this .attr with the raw data, which internally calls this .set attrs, which we could probably call here just to save us 2 function calls. Anyways, and then if we were supposed to tear down this kind of internal storage of observables to maps, or sorry, not observables, of raw plain old JavaScript objects to maps, this is what we would do. Or sorry, hold on, let me clear that. We would tear down this map here if we needed to. Okay.
Hey, Justin?
Yeah.
Do you have some sort of network activity going on in the background? You downloading lots of movies or something? Because it's kind of laggy on our end.
No, I am not. Hold on. I might switch my internet cell phone, or my cell phone's internet. Were you able to not hear any of that? What I just was talking about? How far did I get?
About 60% of what you're saying is coming through.
Chris?
Yeah.
Can you hear me?
Yeah, about 60% of what you're saying is coming through to me. I'm not sure about the others.
Okay.
It's about right for me, too.
All right. Is it any better now that I just switched to a different internet?
Yes.
Okay. Do I need to restart, basically?
Maybe.
Okay. Yeah, next time give me a little heads up a little earlier if you guys don't mind. But let me restart again.
I wasn't sure if it was isolated just to me.
Okay. Yeah, just type a message then, and then other people can confirm. All right. Starting over, how can.Map works. Okay. So can.Map is it provides an attr and a remove attr method that essentially are used to read and write and remove properties. the functionality is broken down into kind of three. For every read, write, or remove, there's tends to be three different functions. Let's think about set. So there's the underscore set will find the nested object that needs to get set. Double underscore set will handle any events, dispatching events if a change actually happened. And then triple underscore set is actually changes the underlying data structure to the new value. So as we'll see, there's kind of every one of these. There's this underscore get, it uses double underscore get, and double underscore get uses triple underscore get. And they all of the functionality and a lot of the functionality of can.Map is broken up into these three layers for when you're reading or writing values. So we're going to talk about that, but we're going to first talk about initialization, and then also I mentioned how there's two other functions, two other helper modules. One is bubble that sets up bubbling. So can.js, if you listen to a change event, any child objects on that map will bubble their event up to the map. So you can actually listen to a change event on a can.Map and know when any of its children change. That functionality is all in bubble.js. Map helpers.js handles the problem that I was talking about before. One of the things that it handles, which hopefully makes sense, is I can create an object, a plain JavaScript object, but I can set that as the value of two different properties. I'd want the map to make so only one instance is created for that object, and that one map instance is created for obj, and it is both the obj1 and obj2 value. You guys with me there?
So far, so good.
Okay, cool. So this is what a lot of what can.Map helpers does. It handles a lot of like weirdly recursive or cycles and maps. That's what its job is to do. Certain things like that I just don't want to stick in can.Map itself. Okay, so I'm going to kind of skip this setup stuff. I'm going to talk more about when you instantiate a map, what happens. So you create a new map, a warehouse for all the raw data is created, and that's underscore data on a can.Map. We label the can.Map with a unique ID. Then we set up any computed properties on that map, and I'll come back to what happens there. Then we use the map helpers to say that we're creating this instance for this plain JavaScript object. And it stores that, so if it sees this object again, it will reuse this instance that's already being created. Then it gets any default values with this set of defaults and essentially combines them with the data that was passed in to pass that to this .attrib, which will set all of the values. Okay, and then finally it tears down this mapping if it needs to, this initial mapping from any objects to the actual instances that are created. So any questions so far?
Nope, so far so good.
What? No, so far so good?
Yeah.
Okay, cool. All right, so now let's talk about how computed properties are set up. Okay, so computed properties, now this default setup computed properties behavior isn't really needed because we're trying to deprecate creating computes directly on can.Maps. What I mean by that is some of you might have ever done this. You could create a can.Map, and I could do something like full name, and I could do can.Compute, and pass the function. And this would set up full name to act like an attribute that would this dot after first. This allowed me to something like this. And you would pass it a first and last. This allowed this type of behavior, but can define is how you should be doing this. You shouldn't be doing this anymore, but it was supported. But both define and set up computed properties, the define plugin actually overwrites this to add its own computed properties, but they both make use of a helper function called addComputedAtter, which takes the map, the attribute you want to add, and a compute that you want to represent the computed property. We'll talk about what data structure this sets up so that works in a little bit. And now I'm going to skip over to like where the real action is, and that's the atter method. So the atter method, all that does is just checks the signature of what was called, and then calls a lower level function. So if you, for instance, didn't call it with any arguments, atter was undefined, that means you're trying to get all attributes. If you called it with something that's not, if atter is not a string or a number, that means you're trying to set, it's probably an object, so you're trying to set attributes. And then if it's calling with one, it tries to get, otherwise it tries to set. So I'm not going to look into get right now, I'm going to look into set, because when you're instantiating an object, you're going to be calling set afters, which really calls set. So this is going to set with a key and a value. We'll ignore what keep key does for right now. What that does is, if there's a dot in your atter, then it's going to take what's on the first kind of key value and the remainder, and essentially it's going to get that current value, and if it's map-like, it's going to then recursively call set on that. So set essentially calls itself if it's trying to keep setting a nested property, until eventually there is no more dot, and then it's going to call the double underscore set. It's going to call double underscore set with the attribute that's trying to be set and the type converted value. So this might be an object right here. What type is going to do is turn it into an observable object. And you can see here it's using that map helpers, get map from object. This uses that internal store of given a object, given a plain JavaScript object, what might be the cached map that we've already created for it. Now, just to see who, like, get you guys engaged in thinking about these kind of problems, how do you think if that is set up? What do you think's going on under the hood to make something like that work? Where we have a plain JavaScript object, how do we create a map that maps plain JavaScript objects quickly to an instance that's created for them?
I got nothing.
Who's ever on the recruiting team should have a very good. Is anybody here on the recruiting team? Because they should have a very good understanding of this, because this is one of our like recruiting questions nowadays is related to this.
Do we walk the proto chain?
We do not walk the proto chain. What would walking the proto chain help us with?
It was a shot in the dark. But you would compare like the original object used to create the map to what object was passed to get map from object.
Yeah. So, but you would have to you'd have to look at every single object. You'd have to look through an array of all of these potential values that you've created, right?
Yeah.
So that would be like inefficient because as if you were creating a lot of maps, every single that would be like an n squared because every single map would have to compare for every single like map value or plain JavaScript value might be trying to set as an attribute. It would have to check against all others that have been created. Which if you were meaning if you're creating like n maps, it would be n squared checks.
Are you doing something similar to creating a hash map?
Well, normal objects are hash maps, but their keys can only be strings. So now that I've got you guys engaged, thank you for, by the way, everybody. Thanks, Chris, for trying to throw your hat in this ring. This is in Map Helpers. The way we do it is in this add to map. You can see I put a lot of comments about this, so it makes sense. What we do is we give every plain JavaScript object a special hidden ID that's unique. And then by that ID, we store the object, the plain JavaScript object, and the instance that was created. Then this get map from object, it passes the raw JavaScript object. Well, we're just going to look at its CID, and if there is one, we're just going to return the instance that was created.
So you are just creating a mapping.
We are creating a mapping, but the trick is you add a unique ID to every object temporarily, and then that's what that teardown function does. There's this teardown function that goes and removes all the CIDs because we don't want to add properties to plain JavaScript objects that people are passing to us. We don't want we want that to you pass something to can.js, we're not going to change that data out from under you, right? So we're temporarily adding a unique identifier so that we can delete it later.
When is later?
Later is so that's in the instantiate. Very good question. Later is so when you instantiate a map, if it's down to the first instantiation of its kind, it's not doing nested, it's not part of a nested instantiation. If it's the first instantiation, add to map returns teardown mapping. And then it just happens after this.adver is called.
So that technically means that if you initialize two different maps,
yes,
with the same child object, the child object is going to be a different child map, right?
Yes. If you did something like this and then did new can.map A-O, and then did new can.map B-O, and let's say this was A, and let's say this was B. A dot, I'm just going to be use shorthand right there, A would not equal B dot B. Right? However, we do this, A dot A is equal to A dot B. Right? So, I mean, we could, I've thought about it.
So I was just going to mention another thing that was important so that we don't have infinite recursion when converting, part of it.
Yeah, it's actually very important. Because if you did something like O dot O equals O, you need to know that you've already created an instance for the O value. So you don't keep trying to make your child over and over and over again. So this is also extremely important for that. Okay. So anyway, so kind of stepping back again through where we were, after was called with all the things, and it's going to call essentially set for every property value, with every attribute and every value. And this underscore set essentially just finds the actual object you're trying to set, and then once it's actually found the actual object, it calls double underscore set with the attribute and the type coerced value, right? So the define plugin hooks in to this and overwrites it so you can do any other custom defines. But the default type is really just to take, if something, make sure if you've already created an instance for it, we'll use that. Otherwise, if it looks like an array, create a list, and if it looks like an object, create a map for it, right? So then double underscore set, just like all the double underscore set functions, they deal with triggering events. Is their primary kind of thing that they do on their own. So if the value has changed, so double underscore set is always called with the old value or the current value, and this is the new value. If the values are different, then the big thing that this is doing, besides calling triple underscore set to actually set the value, is it's triggering a change event. And this is a trigger change helper that actually just calls can.Batch trigger underneath the hood. But you just pass this the property, how it was changed, the new value and the old value after you've actually set the data. And this is just looking, this is just looking for, is this a new property? If it is, call add, otherwise it's a set. Now you'll notice here there's this bubble set and bubble tear down from parent. I'll talk about what that means, but essentially bubble set sets up value for bubbling if it needs to, and current, it will actually tear down current. This also tears down current. Actually, now that I'm looking at this, I don't even know if this code is needed anymore because I think this takes care of it. Always code review. I've already gone through this code, poured over it, and then you still find other potential improvements. Anyways, that just tears down so that this set sets up value so that it will, if it's an observable, when it changes, trigger a change on the parent, which is this instance. So finally is triple underscore set, which actually sets the values. And this first checks if in this computed attrs object, and this is where like all the computed attributes, data structure is stored. If there is a computed attribute that you're trying to set, well, then just set the compute. Otherwise, you're going to set on that underscore data. And then finally, we do set property values directly on the can.Map itself, as long as we're not overwriting a prototype function or we're not a computed attribute. This I want to go away in 3.0 so that we are only ever storing data on underscore data or inside of the computed property. Okay. So I'm not going to talk about remove, but I want to talk about how get works now. Any questions though?
Why is it checking on that last little bit there? Why is it checking to make sure it's not overriding a method?
So if you try to store a, let's say you try to have a attr attribute or a, what's another attribute, like an underscore set attribute or something like that. We're not going to blow away these functions. Like in each, you can actually have an each attribute. We're not going to overwrite it. It's only going to be kept in here.
Okay, thanks.
Good question. Okay.
I wanted to ask, did you go over a trigger change? Did I miss that part?
What?
Trigger change?
Okay, so yeah, let's talk about that then. Trigger change.
I was playing around with it yesterday, and I scratched my head a little bit.
So trigger change, it's probably different than when you looked at it. But what it does is it just gets an attribute, how it was changed, the new value and old value. And it checks if this is bubbling change events. So it only actually triggers a change event if somebody's actually listened to a change event on it. No reason to do extra events unnecessarily. So it checks if this map is bubbling, then trigger the change event. But otherwise, you're always going to trigger the named event. This is what triggers the named event with the new value and old value, and the type is the attribute that was changed. And then, if you were to remove or add an attribute, that means the keys event needs to be fired. This is a special event that gets triggered whenever a property is added or removed.
So that's actually one of my questions, is what does that special event type do? Or what uses it?
What uses keys?
Yeah.
So there's a few things that use keys. One is the keys can.Map keys function, which returns the array of all key values in your can.Map. So this sends a signal that, hey, I don't care about the values, I just care if a property is added or removed. Well, then if keys is called inside of a compute, well, if a key is added or removed, well, now you need to rerun this function, right? That sends that signal,
okay.
And does that as well. Can each, the utility, make sure it also calls underscore keys on a.
Okay, cool.
Map.
And then this is a bit of a leading question, so don't get upset with me. But I noticed that we pass back to trigger changes. We have like an if how is add or remove. But if how is remove, we still set the type to adder instead of how. So can batch trigger this, type is adder, target is this. So if that was how was remove, then we would have fired off the property name as an event, but we wouldn't have fired off the remove.
Wait, sorry, I'm not sure what you're saying. What are you saying?
So in that type is adder, a couple lines above your mouse.
Type is adder.
Type can batch trigger type is adder. Type property is adder.
Oh, this? Yes.
Yeah. So if how was remove, then we just triggered essentially a set on that adder, right?
A set on that adder? No. We just said that the adder has changed its value.
Right. But we didn't necessarily fire a remove event.
No, we don't fire remove or add events on can.Maps.
Okay. Okay. So the only way to find out if something's been removed from a can.Map is with change, because then you'll actually get the how.
Keys, but you won't know which. You can use keys, which will change.
Okay. So.
But it won't let you know which which key has changed. But you can use keys.
Okay.
We could add I've thought about an add or remove on a can.Map, but it's we just haven't had the need for it.
Okay. So keys would let me know that something was removed, but it's mostly useless because I wouldn't know what specifically was removed.
Yeah, but you could change that. You could just add which value here if you wanted, or the nature. You could add more data here that would let you listen to a keys event and then know.
Okay. Cool.
Added. That's how.
Thank you.
Probably
this will help me solve my my issue. Thanks.
Awesome. All right. Added in value. Good. Sweet. Okay, so let's talk about get. I want to get through this really quick. This is read. This is called whenever a value is read with the attribute to read. So again, underscore get, that just handles like, is there a dot? If there is a dot, well, then you're going to kind of get the next object, that object left of the first dot, and recurse and call get on that. And then eventually, once you get to the actual value you want to get, you're going to call double_get. There's a little bit of other stuff here that I'll talk about. I'll come back to that in 1 second. But then double_get, that calls can_observe. So it's saying that I want to read this value. Right? This is dealing with events. This is like we learned about can_compute last time. This sends a signal. I want if this is inside of a compute, make sure that compute binds to this event name on this object. Okay. Now there's a little bit of extra logic in here that there's a little bit of extra logic in here because you can.JS actually allows you, if you created an object like this, new can.Map, you could do something weird like foo.bar true. And then if someone did something like on the map, m.answer foo.bar, well, we'd want to return that true. So there is a little check here to say, hey, well, just try to get that dot value anyways. And if you do get something back, then make sure it's observe and then return that. So there's a little like escape hatch for that circumstance in here. Then finally, the triple_get, that does very similar to set, where it checks if it's a computed attribute. If it is a computed attribute, read the computed attribute. Otherwise, read from data. Now there is a final thing where get, we want to sometimes be able to just give me the raw data object that is backing this whole observable. That's why _get. If you didn't pass it any arguments, essentially, then you return the actual raw data object. And that's used a few places. Kind of hacky. Maybe we could create another method, but it's just convenient. Okay. Any questions about get before I turn on to how binding works?
No.
Okay. And computed properties. So let's talk about how computed properties work. And that is a combination of that one helper that we kind of looked at, like add computed attr and blind. Okay. So I'm going to actually start with the helper. Add computed attr. Okay. So this function is called by the define plugin and by just can.Map itself whenever it wants to add to a map a attribute that is represented by a compute. And this function is really simple. All it does is stores on computed attributes an object with that compute, with how many bindings are on that property name so far. So if I'm listening on full name, if I bind to that map's full name property, this count will go to 1. And then it provides a handler that if this handler is bound to this compute's change event, it will trigger on the map a named event with the same attribute. So it'll trigger a full name event on the map with the new and old value from the compute. As the compute changes, essentially we're just forwarding all events onto the can.Map. That's what this event handler does.
That's incredibly simple.
Yeah, cool. All right. So, any questions from anybody else about this? Does that make sense? Like we're just this function. I'll show you where we bind on this compute. We bind this handler, and all it does is just say, okay, we're listening to this event, but now we're going to just send that event on the map.
So that's basically making it so that the events are the same as if it's a regular attribute for computes.
Yes, exactly. Cool. Good question. Okay. So let's take a look at back to map, the bind function, which actually does all of this. No, not the bind. Not that bind, at least. Here's the other bind. Okay. So here's where you bind on a normal can.Map, right? And let's say for the sake of argument, we're binding on full name. Well, that's going to see that you have a computed attribute named full name, and it's going to say if you have not bound on that property before, we'll set count to 1 and bind on that computed handler that we saw. And if you've already bound on that, well, no need to do anything. Just increment the count of the number of bindings. And the reason we do this is so that as you're unbinding, if the count ever gets back down, if the count is 1, that means it's about to be 0, then we can unbind that binding so we're not doing any memory leaks. All right, we'll say, okay, we're no longer listening to this compute. So the compute is not listening to anything to make sure that there's no potential memory leaks. And
can you go back up to the where you incremented the count? Okay, cool, thanks.
Okay. Okay, so now I'm going to talk about how bubbling works, and that is the last thing I want to talk about. Let me just make sure that that's indeed the last thing. Okay, so that's the last thing to talk about because it's like the last kind of, well, and serialization real quick, but that won't last long. Okay, so let's talk about how bubbling works a little bit. Okay, so there's this bubble helper, and I'm just going to kind of talk through why bubbling is complex. So if anybody needs a reminder, when you listen on if you bind on a change event in can.js, which we actually want to stop people from doing, but a lot of people do it, and I at least want people to understand the complexity that's involved there. When you bind on a change event, what this does is it goes to any of your children and sets them up so that when a change happens on them, it will trigger a change event on the parent. Now, it also handles if an item is added while this bubbling is taking place. Well, it handles setting up bubbling for that new item and removing bubbling on any previous items. Any items that are removed, it needs to unbind so there's no memory leak, so it's not forwarding to the parent. So there's a few functions that deal with all of this stuff that this bubble helper provides, right? So first one is when bubbling is first initiated, that first time someone binds on the change event, we need to potentially set up bubbling on every single child item. That's handled by bubble bind. Bubble unbind does the opposite. So if you've unbound your last change handler, we need to tear down all of the bubbling. That's handled by bubble unbind. When bubbling is running, if a new item is added, a new child item is added, you need to set up bubbling from that child to the parent. That's handled by bubble add and bubble add many. This does one, this does multiple. If an item is removed, that's handled by bubble remove and bubble remove many. The tear down it's finding, and finally there's a bubble set that handles when a property is replaced. So it should set up bubbling on the new item value and tear down bubbling on the old value. So let's look at bubble bind real quick and maybe just walk through this. So bubble bind is called whenever a can.Map is bound. So let me just go to see here in my bind function. We just say, hey, bubble bind, this map instance is listening to this event. Now, if this is an event like change that needs to set up all this bubbling, well, go ahead and you take care of that for me. All right, pretty simple. It's just like you just call bubble bind and it should do all of the hard work for you. So what bubble bind does, now you'll notice this there's a lot of code that's checking if you're not initializing, then do stuff. Because if you're in the initialization phase, then you typically shouldn't be doing a lot of extra work. And there's this parent initializing prevents like work that really doesn't need to be done. Because you really shouldn't be setting up bubbling because nobody external could possibly have bound to you, right? To actually be able to set up bubbling. So that's why that check is there. So this bubble events, given a map and an event, returns any events that need to be set up for bubbling. Normally, if change is here, it's going to return an array that has the change event in it. I'm not going to go into why you might have multiple events today. That's a discussion for like can.Map list and the sort plugin, which I think also does this. Anyway, so if you have a bubble event, like a change event, that needs to be set up for bubbling, essentially it's going to go through each of the events in this bubble events. Let's just say there's just change. And for the change event, if you aren't, there's this bubble binding that tracks, just similar to how we track the number of event listeners to computed properties, we track the number of event listeners to bubble properties. So if you haven't set up bubbling for change yet, well, if you haven't set it up yet, then indicate that it has been set up. And then what you're going to do is call bubble the children of parent for a given bubble event. And what the children of does is so goes through each child. We call underscore each because underscore each is not observable. We don't want, if somehow this code happened to be in a compute, we don't want this code to be run each time an item is added or removed from the parent because can.Map handles that itself anyways. So anyways, children of goes through every child and says on each child, bubble to parent. So it provides the child, which might be a nested can observable, to the parent, gives it the property of that child, and gives it the event name. And here in toParent was where a lot of the magic happens. Okay. Again, this is the child. We want to bubble its events to some certain event to its parent. This is going to use can listen to, which if you're familiar with Backbone, allows you to say, this basically allows you to, like, instead of associating the event, the object that's producing the event, with the event handler, it produces the thing that's receiving it. So you can say, I can easily kill all parent event handlers that are related to this child. So I can say, stop listening to change, stop listening to all change child event handlers for this parent. It's quite useful, but Backbone has better documentation for this and uses it heavily in Backbone, but it's actually a really nice function. Anyway, it says, listen to the child event name, and when that happens, call this function. And what we do is essentially this arg0 is going to be the attribute that was changed for any change event. And we're going to say, if it's a list, we're going to get the index of that list, so we're going to get 0, 1, 2, 3. Otherwise, if it was not, just a normal can.Map, just use the property here, like name or something. And we're going to say, name, add that to the event name that the child produced. So if the child produced like first, but our child object was called name in the parent, we would get name.first right here. Otherwise, if it was in the list, we would get 0.name or something like that. Now, on the event object, we reuse the same event object for every single dispatch so that we can keep track of every instance that we've dispatched this change event on to detect any cycles, so we prevent any cycles. So if there was a cycle, if we've already dispatched this change event on it, do not dispatch because you can create an infinite loop. And then finally, we trigger on the parent the kind of the modified change event. And then if it is a change event, now there are some types of events that we want bubbling that are not change events, but only for change events do we want to also trigger a named event. So this triggers like taking the attribute that was changed and just triggers a named event on the can.Map. So that is how bubbling works for the most part, right? All the other like add, all these other functions here, like add or set, call that bubble to parent appropriately. Okay, one final thing is serialize. Any questions there before I move on?
Nope.
You guys finding this kind of hopefully still a little valuable? Like, you at least, if not understanding the code exactly, the concepts used to build these structures?
Yeah.
Okay, cool. Let me know if I need to, how I can improve this after this talk. Anyway, so one final thing. Let's talk about how serialize works, just because there's a little bit of complexity there. Mostly around that you don't want to create cycles again, because you can have nested objects that point to themselves, and you want to serialize them correctly. Where's the serialize function? So the serialize function calls a map helper serialize function, passes the map, passes it the method it wants to recursively call on all nested observable-like objects, which is in this case serialize, and pass it the data, what type of object to put data into. So as you kind of find each individual property, you're putting them into this object right here. You'll notice that attr, get attrs, looks the same way, except that we say we want to recursively call the attr method and store it in an object. Can list calls the same thing, but passes it an array. So every item kind of gets serialized into an array. Now what map helpers serialize does, now I wrote this, and maybe it'll be easier if I show the actual code for it. Just this how I structure this. This is a technique which you guys might see once in a while. If you have a local variable that a function should access that nobody else should access, and you don't want to stick this local, I don't want to stick this local variable like way away from the code that's actually using it. It's kind of like, oh, where the hell is this serialize map? One way of making it so that kind of everything can be together is I surround my actual function that is the serialize function with a self-invoking function. And that way I can have little local variables kind of trapped in just the call object of this function, where this function is defined. So, anywho, so this serialize function, it's kind of doing similar to what the other helper, the get map value or whatever that was doing for instantiation. This is doing something very similar for serialization. What it does is, given the map, given the function to call, and given the kind of where you want to be storing all values on it, it keeps in this serialized map the attr, depending on how it was called. It kind of keeps them. Do I have actually an image of this map somewhere? Maybe not. This serialized map is is it up here? No. Okay, so serialized map is essentially a map of, it goes to attr, and then within attr, for every CID, the actual resulting serialized value. We need both serialize and attr, because serialize, a lot of times people will write their serializers to call attr. So we kind of have to store both representations for serialized map. And all this does is we just check always for every value. If we've already serialized it, we'll use the already serialized value. So we go through the map that we're wanting to serialize, check if we've already serialized the value. If we have, that's the result. Otherwise, if the map supports a triple underscore either serialize or attr method, we will call that to do kind of custom serialization by individual properties. This is how the define plugin overwrites triple underscore serialize to get the end result. Otherwise, you call this map helpers get value, and all that does is, if it's a map, well, then you're just going to keep either recursively calling serialize or attr on the map. But if it's not a map, then you just return the actual value, and that's the result. You stick that in that object that was passed, and that's what you return. And make sure you, if you are the first person to call serialize, make sure you clear the serialize map at the end of it. So freeing up any memory base. All right, that is the high level of can.Map. Any questions?
When you called serialize, the second argument was a string that said serialize. What's the other option? Is that attr?
Attr. Yeah.
Okay. Okay, thanks.
It's basically what function do you want to recursively call on any map-like, object. I want to keep calling, that's why attr and both serialize use this helper. So it's like attr recursively calls attr on any nested child. Serialize recursively calls serialize on any nested child.
Okay, thanks.
Cool. So that's kind of can.Map. Any other questions?
What will the next impromptu topic be?
I'm thinking of actually talking about, it'll be a much smaller one. I think it'll just be about how the events can batch, like how events are dispatched, how can dispatch, can batch dispatch, and all of those, and trigger, how all of those things work, just like actually store event handlers and how event handlers are called back. Because both map and compute use that, and I've just kind of like shadow, just kind of wave my hands over, oh, these events are dispatched, but nobody probably has any idea of how that actually works underneath of it.
Awesome. Do you see any value in going over the define plugin by itself, or do you feel like the compute topic mostly covered it?
The define plugin, I don't know. That would come after live binding in my order of preference, or needing things to get done, because I kind of want to go like the define plugin depends on can.Map, and it's very important, but it's not there's not as much there that's like actually I think is hard to understand if you understand how can.Map works and events are dispatched and how computes work. But the observable, or the live binding stash and all of that stuff, there's so much code there. It's so important. I'm going to do that next. I'm working towards that.
All right, I get it.
Yeah. And then maybe computes too, actually, or components. I'll probably hit before the define plugin as well.
So you've made a bunch of changes to this just recently to the document, the doco docs.
Oh yeah, they're totally different. So this hopefully David has to look into it, because I didn't see if they were published or not. But once I push this, it should be updated in Liner. So if you guys want to read through it, it's actually really good to read through now. I think. I'm patting myself a little bit on the back here, but I feel like it's almost readable now. Like it's almost literature. It's not Shakespeare yet, but it's on its way. where you could actually learn a lot. And I actually rearranged all of the functions so there's kind of like an order to everything. Like, oh, it's the it's in setup type, instantiation type things first, then it's attr followed by all the getters, all the setters, all the removers, then the multiple, things dealing with multiple reads or writes, then followed by binding, then like kind of the kind of little helpers at the end, computes each, and that's it. And then these things are all broken up much nicer now. So it's hopefully if someone does want to really read through it and understand it now, you can go to the doco, and this is a very useful tool for understanding can.js.
So it'll be in Miner, and does that have to be built, or will that just be already pre-built and sitting in Miner?
It will be on the website. So it should be. This was at some point. Doco link.
Oh, cool.
I think we established that the new ones are not being built right now.
This is not my. This is not. Yeah, this is not the one that I've updated yet.
Okay.
Yeah, but it will be. Hopefully, early next week or this weekend, we'll get the updated can compute and updated can.Map if you go to 233.
Sweet.
Yeah. Cool. Awesome. Okay. Cool. All right. Thanks, everybody.
Yeah, thank you.
Thank you.
Talk to you later. Have a good weekend.